In this video of fundamentals of electrical circuit, we're going to cover admittance or 1 over z or y parameter. As we've discussed in the earlier videos on this topic, we will be focusing on writing parameters that completely describe two-port systems. So Y parameter, as the name implies, is describing any circuit that fits the two-port definition in terms of 4 parameters that are collectively called Y parameters. So the Y parameters are going to be, we refer to them based on their location on the matrix. So this is a 2 by 2 matrix. So you got Y1, 1, Y1, 2, and then you got Y21 and Y22. So this is referred to as the Y parameters. Now, as we've done before, what this is doing is basically describing a system of equations, and typically we write that system of equation in this form. We have a vector here. It's I1, I2, and then this matrix is multiplied by V1 and V2. Okay, using our knowledge of how matrices multiply, we sometimes like to, if it helps us solve the problem easier, sometimes we would be writing this as I1 is equal to Y11 V1 plus Y12 V2, and I2 we write as Y21 V1 plus Y22 V2. So these are the Y parameters, the admittance parameters. This is the equation associated with it. When somebody gives you a circuit to analyze and write the Y parameter for it, you always use the simplest way you can do this, which fundamentally, because of the way the equations are set up here, if you assumed that port A was short, so port 1. So if you assume port 1 is short, then that basically tells you that you have V1 equal to 0. If I take V1 equal to 0 in both of these equations, then I can find out what the parameter is in terms of I1 and V2. So we could go ahead and go here and write Y12 is equal to I1 divided by V2. And since this is the I over V, so it's going to be amp over volt, this is really going to be admittance or mhos or Siemens. If you apply the same thing to the second equation that said V1 equal to 0, we're going to be able to say Y22 is equal to I2 over V2. As you're going to see later on, we're going to use these relationships if somebody asks us to find the Y parameters. The other thing we could do, we can kind of say next, why don't we make port 2 short? And if we do that, that basically means that we're guaranteed that V2 is equal to 0. So now if we apply it to the above equations, what we're going to get is now Y11 is equal to, under this particular condition, it's equal to I1 over V1. Again, the units are mhos, upside down, ohms, omega. And then Y21 is equal to I2 over V1. Okay, so these are the rules. Let's go ahead and take a simple example and see if we can derive a set of these equations for a relatively simple circuit, but is simple yet it allows us to apply our knowledge of KCL and KVL to analyze it and be able to find all the Y parameters. So let's say someone gives us the circuit such as the one here. It's a relatively simple circuit, and we're gonna get that copied, copy it, and let's go ahead and paste it. It's always a good idea to draw the circuit for every case. So I'm going to take that circuit and I'm going to paste it let's paste it once now, and then we'll come back and paste it again. All right, so here is the circuit I did. So let's go ahead and apply the first set of equations that we were given here, which basically said, why don't we go ahead and make V1 short, which means V1 is equal to 0. The condition we have is we're going to short it over here. Okay. Now the question is, if I short it over here, I need a bunch of equations to deal with. If I'm going to short V1, that basically, and then the next thing I need to know, if I want to find out Y12, I got to find a relationship between I1 and V2, and the question is, what would be the best way to find that? Well, one would be I think the simplest way for this might be for us to write a simple couple of simple KVL equations. And let's see, if we say let's call this one I1, or let's just not to cause confusion, let's call this one IA, and then we know IA is the same as I1, and then we call this one IB, not to just get confused with I1 and I2. So if that's the case, and always remember what you're looking for. For this particular case, I am looking to find what Y12 is, which is I1 over V2. So as soon as I find that equation, I'm done. So one thing we notice that I1 and IA are actually the same thing. So I've got the I1 in here, and also I know that the voltage here is V2. So I'm halfway there. So when I do the KCL and KVL for both of those, IA and IB, so let's go ahead and do a KVL at IA. That's relatively simple. It's going to be 100 IA, which is really I1, plus 50 IA minus IB. So that's one equation. The next equation that I can get is, why don't we do a KVL at IB loop? And if I do that one I'm going to get 50 IB minus IA plus 200 IB plus, just the last one we're just going to say plus V2. So I know IA is I1, so I can just go ahead and, let me use a different color so it's easier to see. So this is really I1, this is really I1, and this is really I1. So I got to get rid, if I get rid of IB, I'm done. That's relatively straightforward what we got, because based on this one, we can clean it all up and find out that, so we got 50 I1, 150, so we've got IB is going to be equal to 3 I1. Great, so I can plug that back in here, and if I do that, then I'm going to have an equation which is 50, 3 I1 minus I1 plus 200 times 3 I1 plus V2 equal to 0. Great. So we've got 2 I1 here, 2 times that's 100. So I've got 100 I1 out of here. I've got 600 out of here. And I've got a minus V2 on the other side. So if I'm looking for a parameter, so simply I1 over V2 is equal to 1 over 700 with the minus sign. And if I go back here, I1 over V2 is equal to Y12. So I found 1. It was a bit of work, I admit it, but the process is relatively simple. I'll just keep applying that KVL to this, KVL in this case, yes. The next thing, so that was 1. the next thing I need to find is y22. And if you look at y22, and I'm going to do it up here so we can kind of look at this thing, although I would recommend you redrawing it every time, it makes it for a cleaner result. So if I have an I2 over V2, that means if I knew what the total impedance of this was, I2 over V2 is just 1 over the R equivalent. So 1 over R equivalent. So for this case, it's really easy because 100, as you can see, R equivalent is going to be the 100 in parallel with 50. And then that, so it is in parallel, that's going to be in series with 200. And then this whole thing is in parallel with, I didn't write this down, but this is 150. Somehow we didn't catch it or got erased or whatever. So that is in parallel with 150. If you do all that, this I think becomes 40. That's 200, but in parallel, 200 parallel with 240 in parallel with 150 gives us 92 ohms. Which basically, if you put it back up here, that basically would be my plus 1 over 92. And again, this is moles. If I forgot to put it in there, that's the same thing, the same as moles. Okay. So we took care of whatever port 1 was giving us. We found y12, we found y22. Now the next question is how are we going to find y2? Hopefully by now you've kind of guessed that the process is pretty much the same. So what we're going to do, we're going to come down here and we're going to paste that image. Again, redrawing is a wonderful thing. And what we're going to do here, we're going to comment this for this time. What we are doing, we are taking advantage of the second set of equation, which says port 2 is short, while we can find y11 and y21, which is these two. So let's go ahead and see if we can find y11. That's a little bit simpler. So in this case, if I want to find y11, and we know this side is all shorted out in this particular case, actually, as you can see, let me go ahead and write 150 ohms in here. As you can see, this is short with one, I'm parallel with 150, so 150 is gone. And if you notice, y11 is I1 over V1, which again, once again, this is 1 over R equivalent. And if you look at the R equivalent is simply going to be 100 in series with 250 in parallel. The reason for that is because the other one is short. So that would be basically 200 in parallel with 50. Okay, and that's basically gives us what we're looking for. And if I do a little calculation on the side here and find out what is 200 in parallel with 50, we will find that that is equal to 40, I believe. So hang on. Okay, so that I'm gonna for now say that's equal to 40, so that gives us 140 ohms. That means this is 1 over 140 ohms. Okay, and the next part we have to do, we have to find, so we've so far find 3 of the 4 parameters. We found y11, we found y12, and we found y22. So the only thing we've left to do is y21. So let's go try to do that. So we are looking for y21, which is I2 over V1. So again, once again, to do that, we have to do a KVL. Probably is the easiest way to do it. So this goes away, if you notice, because it's a short. Any resistor in parallel with short doesn't see any current, so might as well put it that way. And then what we can do here, say, okay, if that's the case, once again, just to not get confused, we're going to call this one IA, we're going to call this one IB, and we're going to write the equations for that. So IA is equal to I1, so we can just literally plug it in, so we don't have to do one more insertion. So we're going to say, okay, do a KVL at IA, which is equal to I1, and that one basically gives us minus V1 plus 100, I1 plus 50, I1 minus IB equal to 0. And then we do a KVL at IB, and that tells us that is 50 IB minus I1 plus 200 IB equals to 0. Great. So if that's the case, then we are able to, from this equation, from this equation, we can go ahead and say, all right, we know that IB is really minus I2, so that's minus I2, just the opposite direction, minus I2. So if we clean this up, it's going to be, we're going to have minus 50 I2 minus 50 I1 minus 250 I2 equal to 0. And if we do that, then we've got 100 and 250. So, and we really would like everything to be in terms of I2, which means then I1 is equal to, I'm sorry, I did that incorrectly. So 50 and 250 is 300. So we've got minus 50 plus 300 I2. So we can go ahead and replace anywhere we see I1 with minus 6 I2. Great. So I can go ahead and take this, plug it up here, and see where we go. And of course, and remember IB is minus I2, so we got to plug that in as well. So we got minus V1 plus 100 times minus 6 I2 plus 50 times 6 I2 plus I2, and then that whole thing is equal to 0. So if we clean this up, we're going to have minus 600 here, minus 300 here, that's minus 900, and 50 we have to take away, so it's 250 and 800. So minus V1 minus, so that was 600, that was 250, so we've got 850 I2 equal to 0. What we're looking for is basically I2 over V1, which is basically minus 1 over 850. So now, if somebody says, what is the parameter Y parameter? So the Y parameter for this circuit we just finished, it'll be, we've got Y21, which goes right here. It's going to be minus 1 over 850. We have, based on our calculation, hopefully is right, we have 1 over 140 is Y11, and then back up here, 1 over 92 is minus 192 is Y22. And then what else we got going? We need one more, which was right here, minus 1 over 700. And that is our Y parameter. All of these are ohms. Mhos, 1 over ohm, because these are conductance we're doing, admittance we're doing. That brings us to the end. So simply all we are doing is we are describing the whole circuit in terms of its Y parameter as is shown here. And if somebody gives us a circuit, we use these two relationships to find all the parameters. That brings us to the end of admittance or Y parameters for a two-port network model.